Hello, I'm Rob Marinelli, Director of AI and Automation at Bluewater Media. And today we're going to talk about closing documentation gaps with AI agents. I'm going to give you a couple slides. We're going to introduce the agent, talk about what it's capable of, a high level overview of what it does, and then we're going to get hands on, creating some documents together, going through the documents, looking at how they're visually represented, looking at how they're configured, and ultimately looking at the agent behind the scenes and how all the tools come together to create the documentation agent. So let's dive in first with some slides introducing the agent and some fundamental concepts about what problems we're trying to tackle with our agent. So, closing documentation gaps with AI agents. Documentation is one of the biggest pain points in modern data engineering. As Snowflake environments scale, documentation struggles to keep up. What we've done here at Blue Water is we've built an AI documentation agent that runs inside of Snowflake to solve this challenge. It automatically analyzes code, maps dependencies, and generates consistent, up to date documentation. Today, I'll show how this approach eliminates documentation debt and helps us here at Blue Water move faster with confidence. So, the challenge ultimately is documentation debt. Documentation is one of the most overlooked problems in modern data engineering, as discussed. As Snowflake environments scale, pipelines end up evolving daily, and documentation cannot keep up. So teams ultimately end up losing context, onboarding slows down, and confidence in system changes drastically drops. And we call this growing gap documentation debt. Why does documentation fall behind? Well, documentation debt starts when change outpaces updates. In Snowflake, procedures, views, and pipelines evolve constantly. Sometimes it can happen multiple times in a single day. Manual documentation struggles to keep up with this velocity. The problem gets worse when documentation lives outside of the source of truth, ultimately scattered across multiple wiki pages, SharePoint sites, or confluences. There ends up being no single source of truth, and knowledge becomes fragmented. Finally, engineers naturally prioritize shipping features over maintaining documents. Documentation ends up feeling like overhead, so it gets deprioritized until critical context is already lost. And we've all faced this in our career when something in production breaks and you or your team ends up on the hook for a process that someone that no longer works at the company's designed and it's undocumented or outdated. And this can be a struggle. So what we do is with this combination with rapid change, disconnected systems, and competing priorities, that's why our documentation debt ends up accumulating faster than teams can fix it, and why we have addressed this challenge with an AI agent. Impact of documentation debt. Documentation debt creates friction across almost every workflow. Engineers end up losing time retracing steps, relearning existing logic. Each undocumented change adds up in risk, and small fixes can break dependencies. Institutional knowledge fades, and new hires struggle to ramp up. This is the real cost of documentation debt: time, risk, and loss of confidence. So, here at Blue Water, we've come up with a solution, which is a Cortex documentation agent. And we've built this agent entirely inside of Snowflake, depending on no external tools or resources. It analyzes tables, views, store procedures, and many other object types automatically. Using Cortex and Snowpark, it extracts logic, maps dependencies, and generates consistent documentation. The result ends up being self maintaining, consistent, and queryable documentation. So let's introduce the AI agent. The Cortex agent is completely native to Snowflake. No external services or data movement, using Snowpark to read definitions and metadata, leveraging Cortex AI to interpret logic and generate documentation. Under the hood, we have YAML templates that define the structure for each object type, defining sections like overview, dependencies, and usage examples. The agent ends up outputting Markdown with embedded mermaid diagrams. Everything stored in the Snowflake table surfaced through semantic views, making the documentation searchable, governed, and version controlled. So, why do Cortex agents matter? This is where the transformation happens. Traditional documentation is always playing catch up. By the time you write it, the code potentially has already changed, and Cortex agents helps us flip that model. Documentation is now able to keep pace with your environment because it's generated at the source of truth. Engineers can finally focus on building value instead of maintaining documentation files. When someone leaves the team, Their knowledge doesn't walk out the door with them. It's already been documented and captured in Snowflake. And because everything runs natively, you get governance and compliance built in. New team members can search, browse, and understand your data platform without having to hunt through Confluence and basically ask for undocumented tribal knowledge. This isn't just for better documentation, it's a fundamentally different way of preserving and sharing knowledge across your organization. So, under the hood, this section actually dives into how the AI agent really works under the hood. It's built entirely inside of Snowflake using Snowpark and Cortex. The agent extracts DDL, parses SQL, Python, or JavaScript, maps dependencies automatically. It uses Cortex AI functions such as AI extract or AI complete to interpret logic and produce documentation. Architecture is fully native, no external systems or data movements required. Everything runs securely within Snowflake, compute preserving governance and performance. This design makes the agent truly extensible, reusable, and easy for other teams to adopt. What's the architecture? Well, this is the foundation of how it actually works in Snowflake. The process begins when the agent reads the definition as discussed, whether that's a table, view, or procedure. Each step of the workflow is then orchestrated, driven by a YAML template. This tells the agent exactly what details to extract and how to represent them. Snowpark handles the metadata introspection and structured analysis. Cortex adds intelligence by summarizing logic and formatting results into clear documentation. Every step, from extraction to versioning to publication, stays natively in Snowflake and is audited. The outcome is live, queryable documentation that evolves automatically with your environment. So, the code into consistent visual documentation. The agent starts by analyzing a Snowflake object table, view, procedure, semantic view. It automatically recognizes the object type as discussed, so it loads the correct YAML. Each YAML template defines which information to capture. This can be all sorts of rules, such as including charts, diagrams. This agent will then produce visuals, such as sequence diagrams or flowcharts, making complex logic instantly visual, not just written down. So it becomes understandable even for new team members just joining a project. So this is where I would like to get hands-on and actually show the AI agent in action. We'll make some documents together. We'll look at the documents. We'll go through a YAML template or two. We'll show some audit tables. We'll make a version change or two. And then we'll go behind the scenes and show how the agent's built. So let's go ahead and show the agent behind the scenes. So you can see here we have Snowflake Intelligence. This is where we'll actually communicate with the agent, ask it to generate documents, make changes, whatever you need to do. Also, just to call out, this is not the only way you can interact with Cortex agents. You can also use the REST API. So you can programmatically also have it generate documents. I would just like to call that out. So naturally, we've already had to create some objects for this agent to exist, such as audit tables and tools. So we can have our agent go ahead and document some of those objects for us to see them. So our agent has behind the scenes an audit table called documentation audit and its audit schema. Let's go ahead and generate a document to see what this audit table actually is. So if we go to our agent and we ask it to document table and giving it always a full path of database.schema.object name, our agent should take this request and then instantly validate it against several rules it needs to follow and break it down for us. So let's wait for our agent to create this document. Looks like our agent has now completed documenting our audit table. So let's take a look. We can see here through the thinking steps that it did exactly as discussed, where it went in, it read its YAML for tables, it referenced some charts, best practices, checked the audit, fetched DDL, best practices now against the DDL, any dependencies, generate the chart, version control, write it to a stage, and ultimately audit and clean up. You can see here it executed all of its different tools, and it gave us a nice summarized output. Now, the summarized output lets us know it's documented the object requested, the actual path it's written to, which is always consistent with a database, a schema, and an object type, along with the object name, a summary of what's included in our document, along with version 1.0. So let's take a look at our document and actually see what's inside of it. One of the coolest things we've also made here at Bluewater is we've created something we call the Documentation Hub. And the Documentation Hub is a Streamlit app that allows us to visualize these documents after they're created. So you don't even have to leave Snowflake to actually visualize what we generate. So if we go over to our Documentation Hub, we'll see we now have one file in it. And it's in a nice, pretty markdown format, along with seeing different things such as our overviews, our schemas, our data life cycles, our data qualities, our performance, our usage examples, along with some retentions, compliance notes, and things of that sort. So let's show off how version control works first, or version history works on these documents. One thing I can see that I don't like in this document is it's including citations from our Snowflake documentation that we cannot reference. So let's have our agent remove these citations and issue version 1.1. So if we go back to our agent and we say document table, and we give it again the full path with database.schema.object name, and we can say removed citations referencing Snowflake documentation as we cannot access them. When we ask this request, the agent will automatically detect a version of this document already exists, pull that version from our Snowflake stage, make the necessary edits, issue version 1.1, along with republishing the document. So while our agent runs, we will review together what document it makes and make sure that it did accordingly with the version history. We can see our agent has completed documenting the table and making our necessary edits. So we can see here that the agent has done the same table path, or sorry, stage path, along with issuing version 1.1 instead of version 1.0, with little note that it removes Snowflake document citations. So let's go take a look at the document and see if they're actually been removed. So if we go over to our documentation hub and we scroll through, we can see that all the necessary citations have now been removed, along with our version history has now been iterated up to 1.1. Remove Snowflake documentation citations. So let's take a look to see how is this document actually formatted, and like what determines, for example, this schema table layout. Well, what we have, as discussed in the slides, we have our table.yaml. And from here, we'll see that it has some necessary things such as the path that you see the document getting saved to, some of the sections and layout. There is our schema table that we just shown underneath of the schema section, our overview section with dependencies, data lifecycle, data quality, performance, usage examples. All of these things are defined here in our YAML. Any special cases, times that it should reference Snowflake documentation, which we saw it did since it included citations for this. You can see here that it has version rules, some version footer rules, some anti-hallucination rules. This is ultimately what powers our documentation agent to be completely consistent across all documentation types. And so that way, when we make a procedure, a view, or a table, the documentations can be slightly different while being consistent for that object type. So let's go ahead and let's actually show the audit for these two documents that were generated. If we go back over to Snowflake audit table, we can see here that we have our table with no rows in it from before we generated those documents. If we requery the table, we'll see now that we have two rows. We have our two documents spread out by a couple minutes apart. We see that we have version 1.0 iterated to version 1.0, along with our initial document change summary and a change summary talking about removing the citations. This allows us to bring a data-driven approach also to our documentation so we can track what's been generated, what version are run, how often things are being changed, and all that stuff. This enables you to have a lot more insights into your actual documentation that's being generated. So let's go ahead and let's actually document a different type of object so we can see it make a slightly different format based off some YAML tweaks. We know that our agent already has some tools attached to it. So let's go ahead and let's document this object right here called account usage object dependencies. So if we just grab the name of this object and we go back over to our agent, we can say document procedure. And again, giving it the full path of database schema object name. But since it's a procedure, you have to also include the parameter type. Since Snowflake allows overloading, you technically can have multiple of the same object names. So when we give this prompt, the agent's going to automatically detect we're asking for a procedure and load a different YAML and follow slightly different formatting rules. And we can see it's already detected this off of rule 1 on read YAML. So we'll let our agent run and we'll review the document together. Our agent's now completed documenting the procedure as requested. We can see here based off the output that it's done a very similar path, but to call out, it's put it in a different folder based off of YAML rules, still using the schema and database, while giving a summary of what's in the file and calling out we're on version 1.0 as expected. So we can see in our documentation hub, we now have two files. The second one being the newly documented procedure. And we can see right off the bat that it follows a very similar structure with our overview. But we also notice that there's something different now. There's actually a visual representation of what the procedure does and a sequence diagram. We can see here a visual representation of it doing the calls, parsing through, doing different things of what the procedure does. So if you know how to read code or understand code, this could be a much faster way to understand what the script does without having to go through the whole document. So it's a nice little add-on. We also can see it has the different parameters, how to use them, dependencies, operations, error handling, performance, usage examples. Usage examples are nice because they'll actually give you code that you can use and make tweaks to for yourself, along with our version history. So let's show off our version history in action one more time, and let's do an edit. Let's make our usage examples go from 6 to 5. So if we go back to our agent and we say, document procedure, reduce usage examples to 5. Our agent is going to detect again that this object already exists, pull up the existing documentation, and make the necessary tweaks without generating a new document from scratch. So let's let the agent do it and we will review. So we can see our agent has now completed documenting the updates to this procedure document. Following the same path, updating its version from 1.0 to 1.1, reducing the usage examples as asked from 6 to 5, putting a change summary of that, and all that. So let's open the document and let's take a look. We can go back to our documentation hub, see our document here, see it follows the same format as before with the same sequence diagram. But as we scroll down and we get to the usage examples, we just see now only 5. So here at the usage examples, we do now only have 5 usage examples. And if we go to the bottom with our version history, we can see a new version has been iterated showing the changes. So this is really nice because someone viewing the document can also see how this document has evolved over time, all the changes that have happened to this script. But a nice little feature that we've also included inside of our documentation hub is for someone that's non-technical to be able to understand these documents. So a lot of times people might need to represent someone on a call and they might not be as tech savvy. So we have a little button called break it down for me, which will take any document that we generate and make it much more non-technical and executive friendly. So we'll show it off in action here. This actually uses Cortex AI Complete behind the scenes. So let's let it generate and we'll review the output together. We can see here our non-technical summary has finished generating, and we can see it has a very clean bulleted list, keeping things very basic without talking about code, no code examples, no diagrams. This is something that someone that's much less tech savvy can hop in, kind of understand what the script's trying to do if they ever needed for any reason to talk for it, or have a broad understanding, or just wanted to know for their own sake what the team might be up to and what's everything it's doing. So let's go look now at our audit table and double check now that we should have 4 records in here because we've now documented 2 things together, our table and our procedure, along with 2 versions of each with the changes. So you might now be wondering, how does this all come together? How does the agent know all these rules that it's applying based off the simplistic prompt? How is it knowing to call the tools and form the input parameters necessary? So now let's dive into the actual agent, showing behind the scenes some of the philosophy that goes into putting together an agent. So here we actually have our agent documentation. This is where you would go and talk to the document, assign tools to it, change rules, whatever you need to do. So let's hop right in and talk about orchestration instructions. This is how our agent actually knows how to plan its tasks and choose the right tools. So, what we do here is we give a high level overview of everything possible and kind of what rules we really want the agent to follow. So, you can see we talk about processing one object at a time in regards to memory efficiency. You can see here also we have for each object, here's the steps. These are the steps that you saw on the screen as we generated and we looked through the thinking. These are the strict rules that it'll always follow and apply to every single document it makes, along with some anti-hallucination. Always do these things, tool budgeting, anything you could think of. But what's also unique in orchestration instructions is you want to remove what you don't need, trim out any fat, and keep it as non-verbose as possible for extreme accuracy. Also, underneath, you have your response instructions. This is actually on our screen when we saw the agent do its output. This is defined by those response instructions. Just like here in our thinking, this was defined a lot by the orchestration rules. So if we go back to our response instructions, we can see here very strict rules such as don't give us the full document, don't show the DDL. We do these things to reduce how many output tokens we're actually putting out because every character translates to X amount of tokens. So what you can also see is we have tools and our agent has several tools attached to it, starting with the Cortex Analyst. What's the Cortex Analyst? A Cortex Analyst is what's generating the SQL queries to run against our audit, determining if versions already exist without having to always reference a file and read a file every time first. We also have the Cortex Search Service, which is what references Snowflake documentation in real time. This is a search service sitting on top of Snowflake documentation. So when our YAML says to reference a best practice, this is actually the tool utilized to get the information out of Snowflake documentation. This is what we saw include those citations originally. We also have a plenty of custom tools, which is what the agent uses behind the scenes to actually do the process we're trying to do, such as stage file ops, object dependencies, view graph, documentation object, or audit, and get DDL. Our stage file ops tool is the tool that's in charge of moving files to and from stages, deleting files, writing files. Any interaction with the Snowflake stage is handled by this tool. Object dependencies is how we pull dependency lists when we detect them in the DDL. View graph is very similar but custom tailored towards views. Documentation audit is the tool utilized at the end of the process for every document generated. This is how we log what was actually generated. And our get DDL tool is a tool the agent calls when it needs to actually pull source code. So you might be wondering, how does the agent call all these in a particular order? Well, that's what makes Cortex agents so powerful. If we think of ETL tools, before we had to define different boxes and connect those boxes with failure or success arrows. Think of this very similar with removing those arrows. You no longer have to follow a very specific flow. The agent can become dynamic based off of scenarios, and it knows how to format its input parameters based off something we have called parameter descriptions. Parameter descriptions is what the agent utilizes in building the input parameters every time it calls a tool. That way, a tool can be very dynamic and used across many different use cases. We also have a description attached to every agent, which also gives a broad description, or sorry, to every tool, which gives a broad description of what that individual tool is capable of in different usage scenarios. But this will not include how to call the input parameter. We break that into the separate block for configuring input parameters. And what's unique that we do here at Bluewater is we always use one input parameter for all of our agent tools, and we call it JSON input. This allows us to not have to overload procedures and just pull out what we need from the JSON elements when we need it. And this allows us to embed multiple different functions inside of procedures that we call as needed. So for example, the stage file ops tool can do reading files, writing files, deleting files, all powered upon how that JSON input is originally formulated in. So let's take another look at some of the tools behind the scenes. so we can get a better understanding of what I'm referencing when I talk about the JSON input and what they're capable of. So if we look at our tool definition here for stage file ops and we scroll to the bottom, we can see here that we have a very basic else if statement that will show us all the different actions that can be partaken in the agents. So if we go through, and you will see that we have rename files, move files, copy files, remove files. This is all powered on depending on which action the agent packages up in its original JSON input. So that way we don't have to make a procedure for deleting files. We don't have to make a procedure for writing files. This can all be one tool that the agent can use in multiple different ways. And this ultimately is what makes the process so powerful. Let's take another look at our YAMLs to talk about how those charts were displayed inside of our documents. So here we can see a different YAML, this time for procedures, where it talks about our sections, our diagrams represented, our parameters, and so forth. But we can see a section down here specifically for sequence diagrams and also conditions around them. For example, always include a sequence diagram, but these other charts are optional. This is again just showing how flexible agents can be depending on different rule sets you give it to follow. And YAMLs can be very powerful for following consistent documentation across object types. So I would like to go back to our slides and talk about some more things. So what ultimately ends up being the impact of all this ends up being documentation without friction. Engineers end up ultimately having instant access to accurate, consistent, and searchable documentation. Onboarding team members end up being faster because context lives inside of Snowflake. Institutional knowledge is preserved even as teams and projects evolve. And the result, as shown, is living documentation, always current, always trusted, and always available. This is how we've closed the documentation gap and reduce risk across our environment. This has taken documentations from hours to minutes. Documentation used to take hours and across multiple systems, now down to minutes. Each run is versioned and logged as shown in audit tables for traceability. YAML templates guarantee the same layout for every object type. And once generated, documents can be surfaced in Streamlit as shown. Also, documents can be put inside of search services to be put in a chatbot, which we did not discuss here. The outcome is faster cycles, cleaner governance, and complete trust in what's published. So ultimately, this makes for one place for all documentation. Now, everything is generated and published in one universal location, Snowflake. Each markdown file is stored in a stage and linked to its version and object in our audit table. This gives us a single governed source of truth, allowing Streamlit and Cortex to make it easy for anyone to explore that content visually. It means no more SharePoint folders, no more stale wikis, and no more Confluence pages to update. So in closing, I would like to say I really enjoyed showing off my documentation agent and what's possible in Snowflake. I hope you learned a lot from this and can take some of these teachings and apply them to your business. I hope you also can make some cool documentation on your own and enjoy everything that Snowflake is capable of. Have a great day.